Welcome to Code with Richard, and in this episode, I'm going to solve LeetCode problem number 15, which is 3-sum. And right over here, I copied and pasted the problem, and I'll just read it right now. Given an array of nums of n integers, are there elements a, b, c in nums such that a plus b plus c equals 0? Find all unique triplets in the array which gives the sum of 0. And there's also a notice. It says, notice that the solution set must not contain duplicate triplets. And here is an example input list of numbers that it gives us. And then here is an example output uh, that, given this input, it's supposed to produce. And one thing to notice is that this output is sorted, so we'll need to do that later on. And one thing to, at least that I noticed pretty early on, or that you have to, is that these two lines right here is find all unique triplets in the array, which gives a sum of 0, so we're not going to have any duplicates, and then also emphasizes that the solution set must not contain duplicate triplets. And so one observation that I have of this is, given this input, and I'm just going to copy and paste this input here. And so if we know that we're not going to contain duplicate triplets, if we notice the output has two negative ones in here, and so even if the input has more than two negative ones, so I can just add a couple of negative ones onto here, that the output's going to be exactly the same. Because you can imagine, it doesn't matter if we take this first negative one and the second negative one, or the second negative one and the third negative one, or the third negative one and the fourth negative one. It doesn't matter which ones we take, the output's still going to be the same because we're not going to put duplicate triplets in the output. So here are some thoughts and notes that I have. And so what I just mentioned is that we basically have no duplicates. And another way to say that is that in this example that I just gave with a bunch of extra negative ones, it doesn't matter how many extra negative ones we have, the output's going to be exactly the same. So you notice we only can use two negative ones. It doesn't matter where they are in this list. We can only use two. So at most, we can only use two of any element, which actually is not quite true, because if we have zeros, we can have 3 zeros. So the general case is that we can only have 3 of any number in the input is actually valid. So I'm going to say no duplicates means that any number that exists more than 3 times can be removed. And in the general case, you can have 3 zeros, but in any other solution, let's say there's like -1 and -1, we know we can't have 3 negative ones because 3 negative ones will not add up to 0. This will actually have to be a 2, that for any non-zero number, we can only have at most 2. But for now, we can just say at most 3, and LeetCode actually doesn't check to make sure you make that optimization. So we can just make sure that our input list only has at most 3 of the same element. And another thought that I have is, when I was thinking about this, is uh, you could brute force this. So we want to know that a plus b plus c equals 0. So we could search for every a, look at every b, and c, and then also search every c, and does this equal 0? But we actually don't have to search every combination of a plus b and c. And the reason why is we know that the sum of a plus b plus c is 0. So we can actually simplify this and say we can search all combinations of a plus all combinations of b, but we know this is going to equal negative c. Or I could say that if I'm searching for a c, it's going to equal my negative a minus b. And so we can use this to our advantage to perform a search. And what I mean by this is we can search every combination of a plus b, but if we know what a plus b, what the sum is, we don't have to search the whole list for a c. We can just see if negative c is in a list. And we can actually just do that by putting the sum into, I'm sorry, not the sum. We can just put these numbers and index them and put them in a dictionary. And so this is the strategy that I decided to follow. So I'm going to create a dictionary with every number in this list so that when I iterate over all combinations of a plus b, I can just look up to see if negative c or negative a minus b exists in my dictionary. And if it does, then I know I have my answer. For example, in this case, if we look at this input, we can start with negative 1 as our first number, and we start at 0 as our second number. If we have a negative 1 and a 0, if 1 exists anywhere in this list, we know we have a solution. And that is the solution we see here in this second triplet. And so let's put this down here. I'm going to write down notes. I'm going to create a dictionary. And the dictionary is the first number is going to just be a number. And I'll just say, I'll just call it a number of nums. And it's an integer. And then I'm just going to add the index to this. So in this first example, if I have negative 1 and 0, I'm looking for a 1. Maybe this 1 is not the first element. Maybe it's really further. I have all these elements in an index. I'm sorry, they're indexed in a dictionary. Where is the key? So I look at 1, and then I find the index so I can figure out that I know that the index of this 1, doesn't matter where it is in this list, is not equal to the index of my negative 1 and my 0, and I know it's unique, then I could tell that it does form a valid triplet. So I'm going to these are my indexes, and I'll just create a list of int here. And let me talk about that one more time. Okay. So I have this input here, and I want to create a dictionary. So I want to create a dictionary. And so every key is going to be one of my numbers. And I'm going to give it a list of the index where this exists. So I put my negative 1, I'll put my 0, goes into a list of 1. Then I'll take my next element, which is 1 right here, and that goes to a list with my index is 2. I'm going to go to my next my next element, which is 2, and that goes, I'll just add my index 3 here. And then I hit another negative 1, so I'm going to add my index 4. And then I have my last number, which is 4, and this goes into an index 5. And the way that I'm going to use this is I'm going to loop through for every combination, for every pair of combinations. So I'll say for every element in nums. I will look at every other element in nums. So again, this gives me, in my pseudocode, an A and a B. So remember, what I'm looking for is an A plus B plus C equals 0, or I can say A plus B for every A plus B. So now I know my A plus B here, it equals negative C. So I can ask the question, does my negative of A plus C, I'm sorry, A plus B, exist in the dictionary, which is right up here. So we go to the input and say negative 1 and 0. We look at the negative, the inverse of that is 1. Does 1 exist in this dictionary? It exists right here. I get my index of 2, so I know the position of it. And so that is a possible triplet that I found. And the reason why I need to put the index here is because as I'm iterating over every combination of for A and B, I don't know if what I'm looking up has the same index of the number that I'm looking up, because I don't want to count. If I'm looking up negative 1 and 0, and I look up a sum, I want to make sure that I don't use the same number twice. Okay, I'm going to explain a little bit more of why we need to put these indexes here. Why can't we just put the number here? Because if we look up A plus B, we can immediately look up C, but the reason why we need the index is for deduplication. We don't want to count a number more than once if it doesn't exist more than once. And I'm just going to copy for this example, the input in the dictionary. And let's assume that in this case, there's only one negative 1. So I can take out my index 4 in there, and I'll just adjust this right here. And the example that I have is when we're doing the search of A plus B, let's say that A equals negative 1, we're doing our search, and our B at this point equals to 2. A plus B is going to be 1, so I'm looking for a C. So I'm looking for C equals negative 1. And if I just look at the keys of this dictionary, I can say, oh, I have a negative 1 already. So I have a solution. However, if I look at the index here, if I look at my index, I have an index of 0, I can see that the index of 0 corresponds to the index of A. So this is actually not a unique triplet, because the index of C and the index of A in this particular example will both be 0. And because I don't want to count this negative 1 more than once, because I only have one instance of that number in this list, then I can use the fact that I have the index to deduplicate it and say, hey, this C equals negative 1 is not valid because this negative 1 has the same index as one of the numbers that I'm looking for. So that's why the values of this dictionary, of indexes, has to contain the index of this number. And the reason why it's a list is because there can be more than one in here. So in this particular example, negative 1 occurs more than one time. So we just create a list and to help us do that deduplication. Okay, so let's go ahead and get down to our coding. And so also from, I'm going to copy and paste what we got from LeetCode. We have this 3sum method. Let's see. Oh, I guess the other thing I mentioned is I created some imports up here, and we'll use this later. But let's go through our thoughts and our notes, and to organize our code. So the first thing is that we have no duplicates. So let's go ahead and copy and paste this here. We have no duplicates. It means that any number that exists more than 3 times can be removed. And another way to say that is Right, copy and paste with this comment. At most 3 copies of any number. So I can, maybe I'll transform nums, and I can create some function, and I'll just call it reduce nums, pass it in nums, and this will basically return this list, but take out any number, any instance of the numbers that exist more than 3 times, because we know that we only need at most 3 copies of any number because the output is deduplicated. That's one thing we can do. We know that we also need to create this dictionary. Where's it go? All right, right here. We want to create this dictionary so we can perform a lookup. So we can create our dictionary. And this dictionary, scroll up a little bit. Let's just copy and paste this here. It's gonna go from a number, which is just every number in nums is gonna have a key in here, and the value is gonna be a list of indexes. So I'm gonna call this my num to index 6. And I'm just gonna create an imaginary function, or I'm gonna call a function that doesn't exist, and I'll just call this create indexes and pass in nums. But actually, before we do this, I think in here we should have a check, because if we reduce our numbers, but at this point in time we have fewer than 3 numbers, I think my indentation is off. So I'll say if my length of nums is less than 3, I'm going to return an empty list. And actually, I could probably move it above this reduction, because this reduction will remove any number that exists more than 3 times. Let's just put this at the top as a base case. So we have more than 3 numbers. We come to here, and then if there's more than 3 of any number, we'll remove those, and then we'll create our dictionary. And then in this, after we have our dictionary, we want to search combinations of A plus B. And does this, I'm just going to say, does this equal negative C here, like, for every combination? So we're going to search the combinations and then build our output here. And one thing that I mentioned before, as an observation, if we look at the output that LeetCode expects, these lists of triplets are ordered. So we need to, you can write a note to order the output. Okay, so the first thing I'm going to do when I build my output is I decided to create a set of triplets. Triplets here, which is a set. And this is how I'm going to build my output. And this as my type, this is going to be a set. And it's going to, I'm going to use a tuple. And it's going to do int, and the reason why I decided to do a set of tuples is because these tuples of these ints are immutable, so I can have them in my set, and this will deduplicate any output if I happen to have any duplicates. So this is my potential set of triplets, or where I want to put my output. And let's scroll back up here a little bit. And remember, what we need to do is we need to look at, we're looking for A plus B, and we're going to do a lookup on negative C. So that means we're going to do a search for every A and for every B. So every combination of A and B, do a lookup for C. And so let's just do a loop. So we're gonna have nested loops here. And I'm gonna use I for my index in my range, and it'll be from 0. But I'm gonna put length of nums here, but I'm not gonna go all the way to length of nums. I'll say -1. And then likewise, I'll have j. I need a in range for j, in range, and I'll put this I plus 1 here, because I don't need to use the same number. Again, we don't want duplicates. And this one can go into nums. And we already know that we did this check to make sure that nums, if it has less than 3 elements, we're just going to immediately return. So we can safely put this -1 here. Search. I've been using, scroll up here, A and B and C as the actual number that we're looking for. And so I'm just going to call A in my nums, next I. So remember, nums is our input, and I is our index into that. We know that B is nums. Okay. And I'm looking for a C that equals -A minus B. So now I know that A plus B plus C will equal 0. And I can just do a search for that. So I'll say B. If this is in my num index text, so remember the keys on my num to index are each of the numbers in my original list, and the values of each of these are a list of indexes that the number corresponds to in the list. So if my C, which is -A minus B, or -A plus B, if this exists in my numbered index text, then I have a candidate. So I have possible matches. And remember, the value is of type is a list of int. So this right here, these are indexes, list of int. So these are the list of indexes that correspond to this value. And I just need to make sure that my index, do I have any index in here that is different than I and j? Because if it's the same as I or the same as j, then I can't use the same number more than one time. We can't do that. So let's iterate over these. So for k in possible, sorry. I'm a little bit too ahead of myself. So I'm going to say possible indexes equals I'm going to take this minus A minus B. Right, so I need my possible matches, or my possible indexes, which is now a list. So I look up this value, which is C, -A minus B, which we know exists here. So I get my list of possible indexes, and now I can see if any index is valid. So I will do a search. So K is my index of C. So my K and possible indexes. So it's valid if K doesn't equal I and K doesn't equal J. So I can put a conditional here if K is not equal to I and K is not equal to J. So this means that I, J, and K will all be unique if this is true. Because we know from up here, the way that the indexes are created, that I and J are not going to equal each other because J will go from I plus 1 to my length, or up to my length, but not including it. So in this case, I'll say, yay, we found unique indexes where a plus b plus c equals 0. And I'll just call my numbers that I found that correspond to these indexes. I'll just call them list of numbers. And I know one of them's A. Over here we have A and B up here. The other one's B. And the other one is minus A minus B. Never actually specified that C is to figure out what value that is. I didn't create a variable for that, but that's okay. We know that at this point in time that our value of C is minus A minus B, or negative A minus B. And I'm going to sort this. And the reason why I'm going to sort this is we know if we go back up to our examples here that we know that this has to be sorted. When we submit our code into LeetCode, it's going to make sure that these are sorted so it gets the right output. So we're going to sort these, and then we're going to add this into the set of triplets. So go to my set of triplets, and I'm going to add to the set, and I'm going to create a tuple in here, and this tuple is going to be my list of nums, my first element, list of nums, my next element, and list of nums, my last element right there. So what this says is I have my list of numbers, my A, B, my C. I'm going to sort them, and I'm going to add this as a tuple. There's this extra parentheses right here into my set of triplets. So again, set of triplets is a set of tuples of 3 numbers. And then once I have that, after I've done my search, now I can convert my tuples to my list because my output is an output of tuples. Find the right indentation right here, and I'm going to convert my tuples to lists. And remember, I have set of triplets. So let's copy this note down here as my type. And I actually want it to be a list of lists. So I can just create an output. I know my final output is going to be a list. And now let's iterate through each of these tuples and convert those to lists. So I can have another for loop. And for triplet and set of triplets, so each triplet now will be a tuple, or a triplet of 3 ints. And I'm just going to call this list of nums again. And then here, I'll say triplet, my first element, my next element, and my last element here. And I'll take my output, and I'm going to append this to my output. And the last thing I'm going to do is I'm going to sort my output because that's what LeetCode expects, and then I'll return my output, and it should return my list. So my output is a list of lists. Okay, so now that our main function is implemented, I'm going to go back and implement our 2 helper methods. So let's just go ahead and copy these calls down here. And for this, I need a function. I'm going to call this reduce nums. And nums is a list of int, and this is just the input list, and the output is also just a list of int. And just as a reminder, all this function is going to do is take in this list, and if there's any duplicate numbers that exist more than 3 times, we'll just remove those. Oops. Okay, so my strategy for this is to use a dictionary to keep track of the number of times each number occurs in this list. So I'm just call this nums count. We'll create a dictionary, and this is going to be a type of my number, which is an int, and that's going to go to the count, the number of times that that number exists in the list. So I'll just iterate over all the numbers in nums. So there's 2 cases. One is we've never seen it before, and then another case is we have seen it before. So if my num in nums count, then I've already seen it before, and so I need to update it. And so we'll set it to a self +1. Otherwise, my nums count is the first time I've seen the number, and it just equals 1. And now I want to rebuild nums. And I'll just call this my reduced nums. Reduced nums because I reduced the number of instances to at most 3. So let's iterate for num in nums count. But let's actually iterate over the keys. So num is my nums, and my num count for that number is the value. All right, so remember the key is my number right here, and then the value is my counter. So I'll get my num count, and I'll just create a simple loop where I in range will go to 0, and we need to take the minimum here of whatever we counted and 3. Alternatively, I could have put some logic up here to say, oh, if it's already 3, don't increment it. But I decided just to add this minimum here. So I take my reduced nums, and I'm just going to add my num to it. So this code will allow me, for each of my numbers that I find, look at my count, and go up to my num count, which if it's less than 3, or to 3, because that's the most amount of numbers I want, and add that to my reduced nums output. And again, this changes the order of the nums list, but that's okay because remember our output is independent of order. And the order doesn't matter. We're going to return my reduced nums. Okay. So again, reduced nums will just take in my list of nums here, and then return the output of my list with the number of numbers reduced to at most 3 instances of each number. Okay, so now we're ready for our next function. And this is going to create our dictionary here. So here, this is what it's going to look like when we call it. So this is a function called create indexes. So I'm going to create a function, create indexes, and it takes in my input nums, the list, and then my output is a dictionary of my number, my list. And so remember, what this is this dictionary is the number that exists inside my list, and then a list of indexes that correspond to that number. And so I don't need this there. And so I'm just going to create a dictionary. So I'm going to call it num to index dict, because the keys are numbers and the values are indexes. And we're going to iterate through my numbers, but I want I as my index. So let's just do a loop, and we'll go from 0 to my length of my nums. So I will be an index for every number in this nums list. And let's grab my current number here, which is the value. And now I can just add this to my num to index dict. And I just have to see if it exists or not, because there's two different cases. So I'll just have a conditional. So if my cur num is already inside my num to index dictionary, then I can just add or append my index I to the list. If not, I just create a new list with just that index. So in this case, it already exists. So let's figure out what are my current indexes to this number. And I just look up in my num to index dict, and I look up in my current num. I'm just going to put a type hint here that this is a list of int. Remember, because indexes is a list of int, because there can be multiple instances of a number in the list. Remember, up to 3 instances. So now I can just add it. So I take my current indexes, and I'll just append my current index, which is I. And then I'll just add this, reassign this back in here. Oops, excuse me. This is current num, and this is my current indexes. And then my else case is the first time I've actually encountered this number. And so I can just create a list with just this one index. And then I can return my num to index dictionary right here. Okay. All right, so there we go. We just implemented the second two helper functions that we need. So the next thing we can do is test your code. I actually created a unit test file here through some tests. And basically what this will do is, here's a data provider here. I have my input and then expected output. So this first one is just what LeetCode gives us. And then there's a bunch of other examples. These examples here, none of these actually have any valid tuples. And then here's some other test cases I created down here that show a couple different other cases. This one at the bottom is just the input given to us with a bunch of extra -1s thrown in to test our deduplication logic and to make sure all of that works. I actually was able to run it, but there's actually a couple bugs in here, and you might have actually already caught those bugs when following along. So the first place there's a bug is, oops, excuse me, line 40. Indentation here is a little bit not quite right. And let's see, line 65. So forgot to call the get method here. And then if we go down to line 102, I don't want to return reduced nums. I actually want to return reduced nums. Here's a instance where the naming caused autocomplete to mess up. So let's go ahead and go back to my, and I run my tests and everything looks good. All right. Well, so thank you for joining me in this episode of Code with Richard. I hope you had fun and learned something. If you have any questions, please leave them in the comments. If you're interested in the source code, you can check out there's a link to the source code in GitHub in the video description. And hope to see you next time. Thanks.